everyone, you're welcome to chemistry class with this. Are you a student preparing for your WAEC this 2026? Please make sure you subscribe to my YouTube channel. So today we want to talk about the chemistry practical. The chemistry practical is always comprised of 3 questions, which number 1 question is titration, number 2 question is salt analysis, then the number 3 question is from any other aspect of chemistry. But now I want to talk about the first number, which is titration. Okay, so this year we are given strong acid and strong base. The acid given to us is H2SO4. This is a strong acid, and then we are given the base NaOH. This is sodium hydroxide. So we are given sodium hydroxide, we are given tetraoxosulfacic acid. Both of them are strong acid and strong base. So for the acid, we are asked to measure 5.60 centimeter cube. Then for the base, we are given 4.4 grams of sodium hydroxide per dm cube. Then for the acid, we are also given the relative density of 1.84. The relative density of 1.84, and then we are also given the purity of the acid as 98%. Then for this is the mass concentration. First of all, I want you to take note of this. Since we are dealing with strong acid and strong base, the best indicators we use is phenolphthalein. Though methyl orange can also be used, but the best indicator for this titration experiment is phenolphthalein. You know why? Because we are dealing with strong acid and strong base. Okay, first of all, before we go into the practical, I want us to calculate the theoretical value and then get our expected volume of acid for this titration. So first of all, we are going to calculate the molarity for the acid and also the molarity for the base, and then after everything we calculate the volume of acid expected to get. Okay, first of all, for the molarity of H2SO4 is equal to the volume times the relative density times the percentage concentration. Okay, don't get this wrong. This is the concentration of acid. Do you get? This is not the molar mass. You know that the molar mass of H2SO4 is 98. Don't mix them up. This 98 is different from that molar mass, you know. This thing is telling us that out of 100%, that the acid, that is H2SO4, is 98%, then water is 2%. That's why we say that this H2SO4 is a very strong acid and is very dangerous to the body. So we are always very careful with it. Okay, then looking at this, so this is to say that this 98, for this, we are going to have 98 over 100. 98 over 100 here. So that is to say that, okay, all over molar mass. All over molar mass. So first of all, for volume, we are given the volume as 5.60 cm cube times the relative density we are given 1.84 84. Then the percentage concentration, we are given 98, and this 98 is over 100. So let's just have 98 over 100. Use your calculator. You are going to get 0.98. So here we have 0.98 all over molar mass. Molar mass of H2SO4. I just want to show this for those that will not know how we got that 98. Molar mass of H2SO4 is 98. This is because for the molar mass of H2SO4, we have hydrogen 1 times 2, plus we have sulfur 32, plus oxygen 16 times 4. So this is giving us 2 plus 34 plus 64. Add everything together, you are going to see that what we get here is 98. So that's why the molar mass is 98 gram per mole. So under here we are going to have what? 98 gram per mole. Though the unit is not actually necessary here. So this is what we have at this point. Then, looking at this, use your calculator and simplify it. 5.60 times 1.84 times 0.98 all equal to are having 10.2 all over 98, 10.24. Okay, so with this, what we have is 0.0 0.103. So this is the molarity for acid, 0.103 mole per dmq. 0.103 mole per dmq. So this is the molar mass for K2SO4. Then in the same way, we are also going to find the molar mass for sodium hydroxide. For sodium hydroxide, we are giving the mass concentration. We are giving the mass concentration for sodium hydroxide. So we are not going to calculate it this way. So what we are going to use for this one, we are going to use molar concentration molar conc is always in gram per dmq equal to mass concentration over molar mass. That mass concentration is in gram. Molar concentration is in mole per dmq. Mass concentration is in gram per dmq. Then the molar mass is in gram per mole. Let's calculate the molar mass for sodium hydroxide. Molar mass for sodium hydroxide is equal. Sodium is 23 plus oxygen 16 plus hydrogen 1. If you add everything, you are getting 40 gram per mole. So now let's substitute the value. We are giving the mass concentration for sodium hydroxide as 4 gram gram per dm cube all over 40 gram per mole. The gram cancel itself. Use your calculator. 4 divided by 40 will give us 0.1 mole per dm cube. So we have gotten this is our Ca, while this one is our Cb. Our Ca, we got it to be 0.103 mole per dm cube. All of our Cb, we just got our Cb to be 0.1 mole per dm cube. Then now we are going to calculate for the volume of acid, the theoretical value to get our volume of acid used. At this point, we are going to use the formula CAVA all over CBVB equal to Na over Nb. At this point, we are going to write the chemical equation for that reaction. We have A2SO4 reacting with sodium hydroxide to get Na2SO4 plus H2O. This equation is not balanced. Therefore, to balance, we are going to have 2 here and we are going to have 2 here. This is to say that the acid and base are in 1:2. So our Na is 1, our Nb is 2. Okay, so looking at that formula, we have our Ca given as 0.103 mole per dm cube. We have our Va. Our Va, we don't know it. That's what we are looking for. Our Va is unknown. Then we have our Cb. We got it as 0.1 mole per dm cube. Our Vb is the volume of that pipette that you use during saturation. Our Vb is 25 cm cube. Then our Na is 1, our Nb is equal to 2 from this equation. Now we are going to substitute the value. And remember, we are looking for this. We are going to make this Va the subject or the formula. And by so doing, this is what we are going to have. Our Va is equal to Cb, Vb, Na all over Ca and B. So now we are going to substitute the value into the formula. Here we have Va to be equal to, our Cb is what? Our Cb 0.1 mole per dm cube times our Vb. Our Vb is what? 25 centimeter cube. Then times our Na is 1 all over our Ca is what? 0.103 mole per dm cube times 2. Our Nb is 2. Please use your calculator. 0.1 times 25 times 1 equals to. So at this point we have 2.5 all over 0.206. So at this point we are going to have 2.5 divided by 0.206. and that is giving us 12.14. So our VA is equal to 12.14 centimeter cube. So this is to say that the volume of acid is 12.14 centimeter cube. This trying to tell us that when we do our titration, our value should be around this. Not that it should be exactly this, but it should be around it. It should not be too far from it. Are you getting it? So you can get your value from your titration. You can get your value maybe around 12.1, 12.2, 3.5, 0.6. You can even get 13. You can also get, in fact, it should just be around this. Are you getting it? So after we are going to do our titration, and then we see the value we get from our titration. And please take note of this, very important. Make sure that the value you are using is what your sensor is using. And I do my titration and get my value. Another branch, we also do the titration. Their value and mine may not be the same. So as you are learning it, make sure that your value corresponds to the sensor, corresponds to the value of the sensor you are writing your exam. See you in my next video. Please make sure you subscribe to my channel and also turn on the notification button so that you get the notification for all the exercise, for all the teaching we are doing to prepare for this WAEC practical. See you in my next video. Remember to subscribe, like, comment and share. Share it so that it will reach others. Thank you. Bye.